So before we go into this, I would like to raise a question here. What do you think is the reason behind this? Is the reason behind this juggling of balls? How do you think the juggler is able to achieve this? What is the physics behind this, in your opinion? Okay. See, this is very important to understand and to visualize this concept of juggling here. Okay. Now, if you don't want to go through the detailed explanation, and if you want only the direct answer here, we have it right away. So time between two throws is time of first ball to reach maximum height. So 1 by n is equal to u by g. Therefore, u is equal to g by n. Applying equations of motion, we have v square minus u square is 2as. Bringing in u is equal to g by n. What we get is h is equal to g by 2n square. So yes, now the question comes up: why is time between two throws equal to time of first ball to reach the maximum height? And this is where visualization of the question comes in, and the concept behind it, of course. So you might be now thinking, see, we just need the numerical to be correct, the problem to be solved correctly, get 4 marks out of this, and get qualified for JEE Mains, of course. Well, of course, that's the primary intention of this complete series. But there is no guarantee that the exact copy of this question is going to come for the 2026 or for the 2027 JEE Mains. Instead, there could be a similar question based out of the underlying concept of this one. That is where this line becomes really important. Time between two throws is equal to time of first ball to reach the maximum height. This is the foundation for what? Foundation for juggling. So now immediately the next question comes up. What is that? How did we arrive at this? So yes, we arrived at this conclusion by actually first visualizing the given situation, then trying to understand the physics behind it, and then try to formulate it mathematically, and therefore we come at this. How? So we will have to understand, for instance, in this case, we have taken 4 balls under the juggling motion. 1, 2, 3, and 4. 1, 2, 3, and 4. 4 balls. Now see, throughout this solution, the picture that is represented here, it doesn't make sense with the corresponding mathematical equation. My bad. I realized it after I, after I was working on this. So, and since I use AI for these picture generations, it becomes really tough to spend time, to regenerate them. It becomes really tough. So I've used this one. So don't, get carried away by the faults, by the incorrect representation of juggling in this figure on the right side. But this on the left hand side, which is something that I want you to draw it, take it down on your notebook, will help you a lot to visualize and understand things. So juggling, right? It's very visually appealing. What is that part which is visually appealing? First ball up, second ball up, third ball up. This is where the things become so appealing to eyes. Why? Because a person has all the 4 balls, 1, 2, 3, and 4 in air, and we see these 4 balls simultaneously in air. Okay? It's exactly the reason why this image is not correct. Why? Because 2 balls are in hand and 2 of them are in the air. So to understand how does this happen, it is important to understand, to break it down into 4 different cases. Throwing off 1 ball, throwing off 2 balls, throwing off 3 balls, and then throwing off all the 4 balls together. Yes, it's going to be a bit complex. So this is juggling off only 1 ball. And now let's see what happens in a 1 ball being thrown up. It goes up, yes, reaches the maximum height, it reverses its velocity, and then it comes down. This is not juggling. Why? Because there is no overlapping motion. There is only one ball involved in it. Now, what do you mean by overlapping? We'll come to that in a while. Now, timeline of one ball being thrown up. Simple. The ball takes some time t to go up, let us say t up, and it comes down at time t down, which actually is the maximum time to go up, the complete time of flight by 2. Okay? And this is a sequential process. So one goes up, it comes down. It goes up, it comes down. There is no overlapping here. If it is sequential and not overlapping, what does it imply? It implies that there is no juggling. Okay. Now let's see the case of what happens when we have one juggler and 2 balls. This image here is physically correct. Why? Okay, can you, okay, now this becomes interesting. Take some time, pause the solution here. I want you to pause the solution and tell me, observe this, and tell me why is this representation, this image here, why is it a correct visualization of the graphical representation that's shown on the left? Why is it correct? Take your time. Think of this and then come back. Well, if you can answer this question, you don't need to watch the rest of this. You know how did we come to the equation. Okay? Right. Now. Now 2 balls are thrown, but are not simultaneously thrown. This not simultaneously is the foundation for juggling. Ball A is thrown up. Ball A is thrown up. As soon as ball A reaches its maximum height, you throw ball B. So this ball here is at its maximum height. And now what goes up? This ball goes up. Okay. So while ball B is coming down, what's happening to ball A? It is going up. And at this point, if someone sees this, right? I was trying to draw an eye there, sorry. If someone observes this, what they see is 2 balls simultaneously in air. Okay? So, okay, now, yeah. So what is the difference between 1 ball thrown up and 2 balls thrown up? That's where the conceptual clarity comes when you can differentiate between these two. There is a moment where both balls are in the air at the same instant of time. When I say same time, I do mean the same instant of time, which of course refers to the time of observation, which is overlapping and therefore is the beginning of real juggling. Okay. So, what is the concept of juggling? For a short time, both balls are in the air at the same time, but they move in opposite directions. Like we saw, the first ball is coming down at the same time the second ball is going up. This is what juggling really means. It is not about throwing faster, it is about throwing at the right moment. And what is the right moment? The right moment is second ball being thrown when the first ball is at the maximum height. If you throw the second ball too early, you will not have space in air. If you throw it too late, the rhythm will break. Now, this is something that we don't, it's not our interest. Why? Because this is actually the talent or the skill of the juggler, not something physics into it. So the concept is throw the second ball when the first ball is at its highest point. Okay. Now, what about the timing? If ball A takes t seconds to go up and come down, which means if the time of flight is t, okay, you throw ball B at time t by 2, which means if you throw this ball, if it reaches a height of 10 meter in, okay, if it travels 10 and then it comes back 10 in time t, then you will throw the next ball as soon as the time is t by 2. So this is where you throw the ball. Okay. So at any given time, two balls are in the air. Why? Because you are throwing a new ball every t by 2 seconds. Now let's slowly try to understand to understand the table here, to understand the data and to mathematically represent the visualization of balls simultaneously in the air. What do I mean? At time t is equal to 0, ball 1 is thrown. What has happened to ball 2? Ball 2 is still in the hands. Which is in hand? Ball 1 is thrown. Therefore, I should have written it better. Therefore, ball 2 is in hands. Right? At 0.5 seconds, ball 1 reaches the top. Say, for example, okay? Ball 1 reaches the top. Now ball 2 is thrown. So which ball is in hand? No ball is in hand. Why? Because ball 1 is at the top and ball 2 is thrown down. Okay, there is a mistake here. Now where is it interesting? During the time duration 0.5 to 1 seconds, ball 1 is coming down and ball 2 is going up, which means both of them are not in the. Okay. I get this. The reason why I wrote ball 2 is thrown here, it's just to imply that during this time interval, both of these balls are in air. Now, what happens at time t is equal to 1 second? Ball 1 lands back in hand. Why? Because the complete time interval is exactly 1 second up, 1 second down is 22 seconds. You launched at 0. Okay, my bad. It should be motion is 0.5 seconds, right? 0.5 plus 0.5 is 1 second. So the time of flight is 1 second. Now at 1 second, ball 1 will reach back in hand, which means there is only ball 2 at its maximum height. Ball 1 is caught back again. At 1.5 seconds, ball 2 will land. And what will happen to ball 1? Ball 1 will reach the top again. Okay. Now let's try to understand what happens during the juggling of 3 balls. Now, you can postulate the solution here and try to explain this to yourself by understanding what happened in the case of 2 balls. Now, when 3 balls are juggled, suppose ball A is juggled at time t is equal to 0 seconds. After t by 3 seconds, we throw ball B. After another 3 by 3 seconds, we ball C. Now, all 3 balls are in the air. Okay? Again, we assume here that the time of flight of one ball is t. So let's try to visualize this. So as soon as one reaches the maximum height, right, As soon as, okay, maybe I'll just pause this here for a second. So one is thrown up, it's going up, it's going up, it has reached the maximum height. And when it reaches the maximum height, what is thrown? 2 is thrown. Oh, okay. There's a mistake in this. Okay, now there is pretty much nothing left to do. Oh, dear students, I'm really sorry for this error in the animation here. You know, it's AI, and of course, not the fault of AI. It's my fault that I should have given it more prompts correctly. But anyway, I hope you understand what I was trying to say here, right? Okay. Now, what will be the case if that's juggling of 4 balls? Ball A is thrown at time t is equal to 0. T by 4 second, we throw ball B. After another t by 4, we throw ball C. After another t by 4, we throw ball D. Now, since the throws are spaced evenly at every t by 4 seconds, each ball will stay in the air for a total of t seconds. So once the 4th ball is thrown, all 4 balls are floating in the air together. Each one is at a different stage of its motion. Some are going up and some are coming down. Okay. If you have not taken down any of the previous concepts that I mentioned here, I would humbly request you that you make a note of this at least. Okay. Probably there could be an assertion reason based out of this. There could be statement 1, statement 2 type of questions. Okay. So let me see if this animation has come up well. No, this also is wrong. Why is it wrong? Because 2 is thrown even before 1 reaches its maximum height. So yes, this is wrong as well. Oh, sorry guys, my bad. I should have done it clearly. This is not juggling, which means both the diagrams, the photos and the graphs are wrong here. But I hope you understand the concept here, right? Throw the second one only when the first one is at the maximum height. Throw the third one when the second one is at maximum height. Throw the fourth one when the third one is at maximum height. Okay? For example, say if each ball stays in the air for t is equal to 2 seconds, which means if each ball is having a time of flight of 2 seconds, you must throw a new ball every t by 4, which is 0.5 seconds, to see the process of, or to produce the effect of juggling, you will have to throw it every 0.5 seconds. Yes, exactly. If you have thought in your mind that can this be a potential question for JEE Mains? Of course it can be. You can have an assertion reason question out of this. What time interval could result in what time interval in throwing a new ball is necessary condition for setting up juggling? Yes, that's possible. Now, you'll always have 4 balls in the air because each ball takes 2 seconds to land and you are throwing a new one every 0.5 seconds. Okay. So yes, that is what I wanted to tell you about the visualization part here. Now, what I'll do is we'll also go through the numerical solution in detail, because these are not what you need. Well, of course, you do want this, but you don't need this. But you do need the mathematical part, which is what we'll do next. Okay.